Algebra 2, Unit 10, Data and Statistics. Let's look at the concept of the normal distribution. Let's start with some vocabulary and some concepts. So earlier, you learned about looking at a sample of a population to gather data. Descriptive and inferential statistics are used to make statements and predictions about populations of items or individuals. Often it's helpful to see the data collected in a graphical representation. These graphical representations are data displays. So one of them is a histogram. A histogram is a display of statistical information that uses rectangles to show the frequency of data items in successive number intervals of equal size. So let's look at the example on my screen and in your notes. This is a histogram. It's an example of a histogram showing the frequency of days and number of page views compared to number of page views of a Japanese Wikipedia website. So let's draw a curve across the top of these rectangles to show the general shape of the histogram and data distribution. So notice that it is comparing days with page views. So I'm just going to hit the tops. So where do most of the data points occur? Well, they occur at the upper end of the page views. So at the right or the upper end of the number of page views. So it's not that most people had a middle number of page views. Most people were at the upper end. And so this is what's called a left-skewed data set. To talk a little bit more about this, a left-skewed data set, and it's a left-skewed distribution data set, is where most of the values, and including the mean, which is the average, cluster at the upper end of the data set. And so to name it, so you think, well, why don't we call it a right-skewed? To name it, we look at where the tail is, where the dip in that curve is. So the dip or the curve is to the left. And so we say it's left skewed. Now, if that page view, if the highest amount of days were on the left end, then that would be a right skewed distribution data set. And that's where most of the values, the average, cluster at the lower end. And again, we call it right skewed because we look to where the tail is. Now take a minute and look at your notes page. So at the next two graphs that you see, these are not on my video screen. These are another example of a left skewed and a right skewed distribution data set. And then on there you can see labeled how the mean, the median, which is the middle amount, and the mode, which is the most frequent, how they fall in a skewed distribution. Now let's talk about when the data is not skewed. So when it is what we call normal. So a normal distribution is a data set where most values cluster in the middle of the range, with the mean or the average, and so they cluster in the middle with the mean, and then the rest taper off symmetrically to the left and to the right, and so as values increase and as values decrease. This curve is described as a normal curve. And it is the shape, we call it a bell-shaped curve. Let's look at some examples of distributions now of data. And these are all real-life examples. So a panorama survey was given to the staff and teacher population of Liberty Public Schools. The data distribution below shows the results of how well students consider the perspective of others and empathize with them, of all the respondents nationally from urban areas, and then compared to the 6th through 12th graders at Liberty Public Schools. So notice the graph is your score, meaning LPS, versus the national. And so our score is 65%. So it says compared to high schools in an urban setting, your score is near the 90th percentile. So what we do notice is that it is in the upper end of the data set. and the mean is right around 58%. So nationally, on average, 58% responded favorably to that statement. So this normal distribution shows that the percent of most school bodies responding favorably was around 58 favorable, but 65% of Liberty's 6th through 12th grade respondents responded favorably to the statement. This is above the average for respondents on the survey, and you can see that looking at the graph. Notice that the curve tapers off in a fairly equal manner to the right and to the left. That's what we talk about being symmetrical of the highest point. And it's creating a range of approximately 30% to 75% of school bodies responding favorably. Let's talk some more about the normal curve characteristics. So the value in the curve is the mean, the average, which also occurs the most frequently. The distribution of the curve is predictable in that 50% of the data is above that mean and 50% is below the mean. The average distance from the mean is the standard deviation. Standard deviation means the average distance from the average. Each upper and lower 50% is divided into 3 areas, and you can see that in the normal curve just below and to the right. So 1, 2, and 3 standard deviations from the mean in either direction. A predictable percent of the data in a normal curve will fall between those 3 standard deviations above and 3 below. These percents can be interpreted as probabilities. So the percents follow what we call the 68, 95, 99.7 rule, which indicates that 68% of data falls within 1 standard deviation above and below, and see how I have marked that area. 95 of the data values will fall within 2 standard deviations above and below, and 99.7 falls within 3 standard deviations above and below the mean or the average. This concludes the Part 1 notes of the normal distribution concept, and so you can go to the Part 2 video where we will look at some examples of normal curves.